All right, so this video is for Calculus 2. We're going to finish up 10.3. So I'm looking at my notes here. Let's sketch the normal distribution n capital N 0, comma 1. So this is a standardized normal distribution. So the standard normal distribution is a bell-shaped curve, but the key is that the mu is equal to 0. So this way we can use it for any distribution. If we standardize, we can use the table only for the standard normal distribution curve. Just let mu equal 0, and then one standard deviation to the right, sigma is going to equal 1. If you go 2 standard deviations above the mean, then sigma, or standard deviation, is equal to 2. And then you can go to the left as well for your negative numbers, 1, 2, and 3. Okay. Let's see what else we can say here. So this allows us to use the table to find probabilities of normal distributions when you standardize like this. Alrighty, so let's take a look at this problem. Sketch the area corresponding to the probability z is less than negative 1.00. Z-scores are taken to 2 places. So that means we're going to be looking where we are 1 standard deviation below the mean and everything to the left, because less than means left. So i.e. the probability that z is less than 1.00 standard deviations from the mean. Okay, so here is the picture right here. For z is less than negative 1, the probability, or the area, is going to be the shaded area. Okay, so this probability, we can use a table now. Again, we can't integrate with these normal distributions. So to find the probability that z is less than, let me see where I am here. Right here, find the probability that z is less than 1.00. We're going to use the table found in Appendix C, or you can look on Learn for my sheets that I put up there. And we know the probability by the picture, by the way, is less than 1/2, because clearly the shaded region here is less than half of the curve. So the probability that z is going to be less than 1 standard deviation below the mean is going to be less than 0.5, 0, 0, 0. In fact, so the way you do it is you go to your table and it's going to look something like this. So on this vertical part, you want to look for negative 1.0. You want to look at the integer and then the tenths place. So that's what this vertical column is all about, finding the correct ones unit, you could say, and tenths place. And then this, it will give you the hundredths place, so the 0. So when you look at this row with this column, you get 0.1587. So that is the probability that z is going to be less than 1 standard deviation away from the mean. And that's going to be 0.1587, which is roughly 16%. But just write it to 4 places. The probabilities are taken to 4 places. The body of the table gives you the probabilities, or area, same thing. So getting back to our cat example, the probability the cat will weigh 5 pounds or less is 0.1587. Because remember, with our cat example last video, we said mu was 7 and the standard deviation was 2. So if you go 1 standard deviation to the left of the mean, you're going to be 5 pounds. So I want z is less than 1.00. And we can get that probability because we're using the standard normal distribution. So you get 0.1587. So again, z is less than negative 1.00 with our cat example is like, what's the probability your cat will weigh 5 pounds or less, and it would be only 0.1587. So this table gives left-hand areas or probabilities only. By left-hand, I mean you have the less than sign, because less means you go to left. So we can only use left-hand areas or probabilities with this table in a direct fashion. Okay, let's try another example. Sketch the area and find the probability z is less than negative 2.13. This is going to be a tiny probability. We want to be further than 2.13 standard deviations below the mean. So here's a sketch. Look at that small area right here. Very small area. By the way, I'm using a pasta raw noodle as my pointer. Okay, so by the picture, we know the probability is way less than 1/2. So because this is a standardized normal distribution where mu is 0 and our standard deviations are 1, 2, 3, -1, -2, -3, we get to use the table to find the probability. So use the table in Appendix C to find the probability that z is less than -2.13, and you get 0.0166. And here's a picture of that table, the important part of that table. So you go to the integer part, and then the one place, the tenths place, you get -2.1, but then I want my hundredths place to be 3, so you go to the 0.03, the hundredths place is 3, and where those two intersect is going to be your answer. Okay, so now the question is, here's the $100 question, how do you find a right-hand area or probability? And the way you do that is the complement idea. Let's see. Okay, so let's use the complement idea. If the probability that z is less than -2.13 is 0.0166, then the probability that z is greater than -2.13 will be everything else. The whole area is 1. So you just go 1 minus your probability that was the left-hand area. And you're going to get 0.9834. And here it is. See, that's most of the area. So that's why it's a very good probability that z will be greater than -2.13. There's the quick sketch. Oh, no, okay. Okay, so that's it for that page. Let's flip over the page here. Find the probability that z is less than 0.83. It's always good to draw a picture to see what's going on. It looks like clearly the answer is going to be more than 0.5000. So you look at your table in the appendix, and there's the 0.8, and then there's the 300ths, and where they meet is 0.7967. And this is a left-hand area, so this is the answer directly. So the probability that z is less than 0.83 is going to be 0.7967. Okay, using the complement idea, the probability that z is greater than 0.83, here's the sketch, is going to be 1 minus our answer when z was less than 0.83, because together the two areas, this plus this is going to equal 1, right? Because the whole area is 1. So if you go 1 minus 0.7967, you're going to get the probability that z is greater than 0.83, which is this smaller area. Okay, between two z's, what you ultimately do when you read the notes is you're just going to subtract the probabilities. You never subtract z-scores, you subtract probabilities. Okay, so then when you subtract the probabilities, we're going to subtract, let's see what we got here, sorry. So we're going to go, what's the probability that z is less than 2.10? It's going to be from here all the way to the left. But then when I subtract the probability that z is less than -1.07, I subtract this probability. So you're only going to be left with the shaded area. Okay. So with the probability between two z's, you use less than symbols so you can get the areas or probabilities directly from the table. These are left-hand areas. And then you subtract those probabilities. Okay. IQ scores among IQ scores among American adults are normally distributed. Let's look at this distribution where mu, the average, is 100 and sigma, the standard deviation, is 12. So this is the symbol sigma, which means standard deviation. This is mu, which means mean or average. Okay, so let's take a look at that. So there is our bell-shaped curve because it's a normal distribution. Mu is 100, as you can see. And then to the right, we go in units of 12 because sigma is 12. So one standard deviation above the mean is 112. And then 2 standard deviations above the mean is 124. 3 standard deviations above the mean is 136. If you're beyond the 3 standard deviations above the mean, you're an outlier. Yeah, that's pretty unusual. That's where the Mensa Club people belong. To be a Mensa member, you got to be in the top 1 or 10%, I can't remember, of the country in IQ score. So my friend Marilyn Vosavant, her IQ is way in the tail. So this is called the tail when you get extreme right or extreme left. Okay, so if I want to answer probability questions based on IQs, I want to standardize this. So let's call mu, instead of 100, let's call mu 0. And instead of calling 1 standard deviation above the mean 112, let's just call it 1. So 1 standard deviation above the mean corresponds to 112. See, this is great here because now I can use the table to get probabilities. Okay, so we're going to have to convert these x scores. We're going to have to convert these x scores into z scores. And there's a formula for that. So the z-score for x equals 112 obviously is z equals 1.00 because you're 1 standard deviation above the mean. 1 standard deviation above the mean. Okay, but what about the z-score for x equals 120? See, 120 is a little bit harder because 120, we don't really have it as an exactly 1 standard deviation above the mean. It's clearly going to be more than 1 standard deviation above the mean and less than 2 standard deviations above the mean. To get 120, we're going to use a formula. So here we go. Z-score for x equals 120 will be between z equals 1 and z equals 2. And here's a formula to get z more precisely. Z, here's the standardization formula, which you want to have before, have it written down so you can do well on your upcoming test this Monday. So z is going to be equal to x minus mu over sigma, where x is your real IQ score, and we're going to standardize it into a z-score. And mu is going to be 100, right? So if I want to standardize x equals 120 into a z-score, I'm going to write z equals, instead of writing x, we're going to write 120, minus, instead of writing mu, we're going to write 100, and instead of writing sigma, we're going to write 12. So here we go. Every x value has a z-score. So for x equals 120, z is equal to 120 minus 100 over 12, which equals 20 over 12, which equals 5/3 when you reduce, dividing by 4 each. And then you want to take that to 2 places. So 1.67, z-scores are taken to 2 places. So there you have it. And we knew that z would be higher than 1 and less than 2. So good. If you want to standardize x equals 88, notice that's below the mean. The mean was 100. So x equals 88 is going to be a negative z-score. You'd get a negative z-score to wit, which means, namely, z is equal to -1. Because 100 minus 12 is exactly 88. So 88 corresponds to a z-score of -1, or -1.00. We can get probabilities by standardizing x values into z-scores, and therefore we can use the table. So here's an example. Find the probability that a randomly selected American adult has an IQ score less than 110. You always want an interval, because probabilities and areas, they need intervals. The probability that x equals exactly some number for where x is a continuous random variable is going to be 0. So you always need intervals, and here's an interval. So looking for the probability that x is less than 110. We can't do that directly. We got to convert that x score into a z-score, so that way we can use the table, because we're standardizing when we convert x scores into z-scores. So the z-score for x equals 110 is going to be, again, x minus mu over sigma, which is 110 minus 100 over 12, which is 10/12, which is 5/6. And then on the calculator, 5 divided by 6 is 0.83 to the nearest hundredth. So there's the z-score. So now we can answer this question. The probability that x is less than 110, that a random person's IQ score is less than 110, is going to be given by this z-score. It's the same thing as saying, what's the probability z is less than 0.83? This is a left-hand area because it's a less than sign, so we can pick up the answer directly from the table. And from the table, you should get 0.7967. So again, why do we convert to z-scores? Because we have tables for z-scores to find the probabilities. We can't integrate with these we can't integrate with normal distributions because the function is not integrable. So we use these tables to get our answers. Okay, and then let me go over this last problem because we're running on 15 minutes right now. Find the probability of a randomly selected American adult that has an IQ score more than 100. Let's draw a quick sketch. More than 100, clearly that's half of the area, so we don't even need to do any more work. We can just say the probability is 0.5000. Okay, what about more than 80? More than 80. So that should be more than half of the area. There's a quick sketch, more than 80. That's clearly going to be more than 0.5000. So what you want to do is convert the x equals 80 into a z-score. So the z-score is going to be x minus mu over sigma, which is 80 minus 100 over 12. And that's going to be a negative answer, negative 1.67. So therefore, the probability that x is greater than 80, this is a right-hand area, by the way, so we got to do some fancy footwork. We can't get the answer directly from the table. We got to use the complement idea, 1 minus. So that's going to equal the probability that z is greater than negative 1.67. So we got to go 1 minus the table entry. And the table entry for negative 1.67 is 0.0475. But now we got to go 1 minus that to get the right-hand area. So 0.9525 is the answer. And that looks like about 95% of the graph shaded. Okay, and then the final part, by the way, is just the opposite process. I'll leave that up to you. It's not bad. It's just everything in reverse. All right, thanks for listening. Have a good day. Bye-bye.